Hello viewers, so in this video we're going to look at how to sketch the piecewise functions. So let's say number one here says sketch the function that is y equals to x plus 1 all squared, x plus 1 all squared for x values that are less than minus 1. Okay, let's look at it. Here are all x values. This is what you must do when you sketch piecewise functions. What you can do is you can just draw a dotted vertical line at minus 1 to make things simple for you. Okay, dotted vertical at minus 1, because that's we want x values that are less than minus 1. Let's see the next domain. They say again we must sketch it as x plus 1 for x values that are between minus 1 and 0. Okay, let's look at it. Between minus 1 and 0 is in this domain here. Ne? Now we already have a vertical line that is our y-axis. We don't need that. We are fine. So we know we are going to sketch in there. We are going to sketch something in there. We will see if the function that is x plus 1 exists in there, then we can sketch it in there. Okay. Now the function that is cos x, again they want you to sketch cos x for x values that are greater than 0. The ones that are bigger than 0 are this side of 0, but up to, you must sketch up to pi. Here is pi. Here we have 3, here we have 3 is 1 2 3, and 3,1415 is somewhere here, that is pi. Okay, so we want to come at pi and we want to draw our vertical line there, our dotted vertical line again there. You sketch your dotted vertical line there like that. Now we want to start with the first function, the x plus 1 all squared. Imagine y equals to x squared. This one is simple, you know it, right? Now replace x, you replace x by x plus 1. This means nothing but shifting the function that was here at the origin, the parabola that was here at the origin, with a smiley face because a is positive. You want to shift it 1 unit to the left. Plus means shift it to the left, right? Now it will go from 0, it will go from touching from 0 here. It will go from touching from 0, but it will now touch at minus 1 because you are shifting it 1 unit to the left. Now here is minus 1. It's no longer touching at 0. It was supposed to touch here, but now it touches here. So we plot there. Okay, but we must not include it at minus 1, right? We must not include it at minus 1. But when you check our next function, they say we must include it at minus 1. Okay, so what we can do is we can just check if the function at minus 1 is at minus 1 0, minus 1 0, the coordinates minus 1 0. If the function exists there and this one also exists there, then the function is continuous there. We can just proceed. Let me show you what I'm talking about. What I'm talking about is you have the first one as y equals to x plus 1 all squared. We want to check what's happening with this function at minus 1. We put minus 1 as value of x. Minus 1 plus 1, that is 0. 0 squared. 0 squared is supposed to be squared. I'm sorry about that. This is supposed to be 0, and then we have a 0 as the final answer when we replace x as minus 1. Okay, for x as minus 1. Now let's check the next function when x is minus 1. When y equals to x plus 1, we want to replace x with minus 1. This means it will be 0. It will be 0 as well. Minus 1 plus 1 is again 0. So what you notice is from the previous function to the left of 1, as we move this way, we go to 0. After touching at 0, we continue at 0. And this one, they said we must include it at minus 1. Now, you don't have to worry about skipping or discontinuity at -1. You just have to continue with the function there because it's joining there and it's continuing. Okay, so the function is continuous at -1. Let's look at it on the sketch. So what we have is, remember that x squared, we have this function here. Remember, we must shift it 1 unit to the left. We come touch here. We no longer touch at 0, we touch here. But now we only sketch the left arm of that parabola going up this way. Okay, remember at minus 2, we put -2 here, you get -2 plus 1. This is -1 all squared. -1 all squared will give you nothing but +1. Okay, now the -2 value will go together with the +1 somewhere there. The sketch is not accurate, it's not drawn to scale, so excuse my bad curve. So it will go up like that. It should pass at that point, that is -2 is to 1 somewhere there. Okay, and then you must indicate that is continuing, because they said for all the x values that are less than -1. Okay, they don't stop you, they didn't restrict you. If they said from x minus, between the x values from x is -2, maybe let's say from -2 to 1, then we will stop here. We are going to cut here and erase this part. And provided that they said we must include the function at -2, then we're going to just do a full dot there. We just do a dot and then a shaded dot, and then we continue like that. And this will be the answer. But if they say at -2 you don't include it, this is what you do. You just say, meaning if they say, they will write it like this. They will say x values that are between -2 and 1. When it's like this is what we do at -2. At 1, we know it's going to continue from when we analyze the next function, we know at 1 is going to continue. So we don't, it's not necessary for us to open this one here. It will fill that spot, and so that to make the function to be continuous at -1. Okay, so these are just the basics that you must know to sketch these piecewise functions. Let's look at the next function, that is our x plus 1. Now x plus 1 is just a function of x, straight line, but you must shift it 1 unit upwards. Now shift it 1 unit upwards, or shift it 1 unit to the left. Remember, when you replace x, you replace it with x plus 1. You are shifting the function. On the horizontal axis, that is your x-axis, you shift it by 1 unit to the left. Same applies to what happened to this function here. Remember, we were supposed to sketch something like this, but we shifted it 1 unit to the left. But with a straight line, you can just say it's the same as shifting it 1 unit upwards. Now, it was supposed to come here. The function y equals to x is supposed to come here, this one, y equals to x. But now it will no longer pass at 0. What it will do now is that it will go and touch at 1. So we must just sketch this one. It's a straight line, so you just join the 2 points with a straight line there. But now we are breaking the rules because I passed 0. Can you see? I came this side. This small portion here, I must erase it because I'm breaking the rules if I go there. They said I must stop at 0 with x plus 1. With x plus 1 there, I must stop the function at the value of x, that is 0. I must sketch it between -1 and 0. Remember, I must sketch it only in here. It must only be in there. No other, not on this side of this dotted vertical line, and not on this side of the y-axis, that is our next, our second vertical line. Okay, after this we sketch our next function. Let's see what's happening with our next function at 0. Now this one, they said we must exclude it at 0. In this case as well, we're supposed to open here at 1 and say we have something like that. But now cos x at 0, they say at 0, you must include the function that is cos x, okay? You must shade that spot. So there's no need for us to make a open dot there and then we are going to shade it on the next part. We can just say the function is going to be continuous and write it like this. So you know that cos x at 0 is 1, right? The Mara graph of cosine function is something like this, okay? You know it from high school. The value here must be positive 1 and the value there must be minus 1. And the minus 1 will go together with the 180 degree that they told you now it's pi. You must sketch it in pi radians, okay? You must sketch it in pi radians, this one. Now, because at pi radians, that's when you get minus 1, okay? Now, here is our pi. And half of pi is somewhere here, 1.5 something, because pi is 3.1415. So 1.5 something will be here. That's when you will have half of pi, half of 180, that is 90. Remember, cos of 90 must give you 0. You have your cos function as 0. So what we must do is we must just continue from 1 and say we are going to sketch our cos function. Must go down like that. After going down like that, now it becomes concave up. Concave up, and then there's your concavity changes up to until you reach pi is to minus 1. And this will be your function. Okay, now let's sketch it on a clear sketch and then see the final answer for this problem. Because I think we made this y-axis to stretch our function, or vertically, I mean, yes, we stretch it too much vertically. Let's see. So let's say minus 1 is somewhere there and 1 is somewhere there. What we are going to have is we are going to have the parabola to the left. But remember, it must go through a point that is minus 2, 1. Okay? Now, after sketching something like this, you must sketch again a line that passes through 0 is to 1 and minus 1 is to 0. And then you want to come to 1.5, that is somewhere there. And you want to sketch your cos function, cutting the x-axis through that point. So you want to sketch something like this, and then you want to come and sketch something like this again, the side. After sketching like this, you must remember that at pi, you must exclude the function. So we come at pi, we do a circle there. We exclude the function. The function does not exist at pi. Okay, the function does not exist at pi, but it goes up to until the values closest to pi from the right, from the left, I mean, yes, from the left of pi, the function exists there, but it will not touch at pi. At pi, the function does not exist. Now let's find the range and the domain of this function. Okay, now when you place our ruler, let's place it. It's not perfect, it's 89, it's supposed to be 90. When you take your ruler, what happens is when you go from left to right and you touch the function, that's when you touch the function once. That's when you identify your domain. Okay, let's go. I go from minus infinity, right? I'm coming from minus infinity. I touch the function. From minus infinity, remember this arrow here for the function x plus 1 all squared means that it goes all the way to infinity. Remember the domain, on the domain, given domain, they didn't even restrict us. So when they say you must identify the domain, you just take all of these guys here. All of these guys here will be your domain combined. All of these guys here combined. You write this one, the first one, or this one. You write the first one, you write this one, or this one, or this one. So you write all of them. That will be your domain, basically. So let's see graphically. Graphically, we say we take our ruler, we move it horizontally from minus infinity. The function is still continuous. The function is still continuous. The function is still continuous, touching the leftmost edge of this ruler. The function is still continuous. Up to until this point, now we have to think twice and say, at this point, it is still continuous, but now when it reaches pi, it's no longer continuous, meaning at pi we must exclude. And now we must say domain. For our domain, our x is all the values that are less, not equal to, not but also equal to, all the values of x that are less than pi. That will be our domain. If you don't want to write it like this, the other option is to write the ones that are given there in their domains from the piecewise notation. It's supposed to be minus one, but also equals to the. You say x is less than minus 1, or x must be between minus 1 but also equals to, you include the minus 1, and then you say 0, or the first one, the third one, I mean, x must be between a pi and a 0, but you must include it at 0 for the other one. The whole of this thing here is represented by nothing but that guy alone. So you just write that guy alone, you get full marks. You just interpret it from the graph, you write it like this, and then you get full marks. Okay, let's look at the range of this function. If you look at it properly, you will see that the range goes from, you place your ruler now not vertically, you place it horizontal. We move it from down up. We don't touch the function. We are not touching the function. We go when you get to minus 1, we don't touch the function as well. But just after minus 1 and up, that's when we start to touch the function. That's where the function is continuous. Then we go up to until where? Let's look at it. Up to until up and up and up again, up to until positive infinity. Well, onto tsamaya. So you just say the answer for range of this function will be all the y values that are greater than minus 1. All the y values that are greater than minus 1 will be the range of this function. You don't include minus 1. If we do like this, it's wrong. We must exclude that minus 1 because it only exists just after minus 1 and up. That's the range of this function. Let's look at the next question. So number 2 says to you, sketch the function that is y equals to minus 2x for all the x values that are less than minus 1 over 2. And then you sketch minus 1 over 2x for all the x values that are between minus 1 over 2 and 0, excluding both the x values. Now you want to sketch again the function that is the inverse of f of x. You sketch the inverse of f of x. If f of x is e to the power of x here, so this one has a lot of work in it. We must just first interpret what is the inverse of x. If f of x is this function, it's simple. We can just sketch this function and reflect it about the line y equals to x. That is just a straight line passing through here. The mirror image of e to the power of x along this line. That is our x equals to y. We must just reflect it along that mirror, and then we get the function that is the inverse. Or if you want to do the math and get the function that will result from this given situation that is being told here. Okay, now let's look at it. One thing again to emphasize, I need to emphasize to you, is that you don't need to include all the values that are on the Cartesian plane, maybe in a scale of 1, 3, 4, 5. You don't need that. What all you need is all the values that you're gonna use to answer the question. Those are the values that we are gonna need. Let's see. The first one in the x is minus 1 over 2. I know that at 1 over 2, I'm going to sketch my vertical dotted line. I do that at minus 1 over 2. Remember, I told you from the previous question, this is the easy way to do it. You go at minus 1 over 2 and you just sketch your dotted line like that. And then you go again at 0. At 0 is already sketched. It's not a dotted line this time, it's the y-axis. The y-axis is your vertical line that you need there. I mean, if you sketch a dotted line on top of that, it's not going to make sense. You're not going to see it. So we go to 0, and then after 0 they say we must go extremely far. They don't stop us. We just go for all the x values that are greater than 0, they say there. Okay, all the values that are greater than 0 will be all the values from 0 to positive infinity. Okay, now we're going to sketch this function now. The first one says we must sketch the function that is minus 2x for all the x values that are to the left of minus 1 over 2. For this side, we sketch the minus 2, the straight line that is minus 2x. Okay, so it must touch here, it must come here at 0. It wants to come here at 0 is to 0. But now the problem is we cannot sketch it at 0 is to 0. What we can do is you can just say, okay, let's see what's happening at minus 1 over 2 of that function that is minus 2x. So you just say y at minus 2, at minus 1 over 2, I mean, will be minus 2 into minus 1 over 2. This will result into a positive 1. Remember, we have there a negative multiplied by negative, that is positive 2 divided by 2 is again 1. So we just have minus 2 going together with 1. We have a point there. And then you must sketch through that point. You want to come here. But the problem is you cannot go that way. You have to go to the left of minus 1 over 2. Now what you do is you come to that point. Remember, but we must not include it. Let's look at it. Let's look at this case. It's interesting. We don't include at minus 1 over 2 from the previous function. And on the next function, we also don't include. So this is an interesting point. This one here, we must exclude it and say we are going to have an open dot there. We open it like that. Okay. After opening it like this, you want to follow those dotted lines and sketch something going the very same way. Okay. Now they don't restrict us. They didn't say between these x values. They just say to the left of minus 1 over 2. What you want to do is you want to come here and place your arrow there, showing continuity of the function to infinity, to negative infinity, I mean. To negative infinity, you have the function continuing that way. Okay? But remember to open a dot there, because at minus 2, we don't include. There is no that thing below the inequality sign. There is no this thing, but also equals to sign. It's no longer, it's not there. They just say from the to the left of minus 1 over 2 and to the right of minus 1 over 2. At minus 1 over 2, you don't put it. You must jump there. There must be a jumping there. You must not, there must be a discontinuity there. The function must jump that point. Okay. Now, let's go to the right of Now, let's go to the right of minus 1 over 2 up to until we get to 0. What's happening there? We want to sketch the function that is minus 1 over 2x. This function is the same as minus 1 over 2 multiplied by 1 over x. And this one here, from high school, you know, it's a hyperbola. It's a hyperbolic function. But now let's account for our a. Our a is this whole thing. This constant will be our a, and it's negative. If it's negative, we know that we are sketching this side where we between the negative and the positive axis, and this side as well between the negative and the positive axis. That's when you get a negative a. Multiply both the axes, multiply both the axes or divide both the axes, you will get a negative. Negative by positive is a negative. This is where we must sketch. So we must come in the second quadrant and the fourth quadrant and sketch the solution in there. But now the domain that is given for that function restrict us to sketch it from minus 1 over 2 up to 0, meaning only in the second quadrant. In the fourth quadrant, we are not involved in that case. We don't sketch anything in there. We don't involve ourselves into a big trouble that we cannot do away with. Okay. So you just put x as minus 1 over 2 on that function now and say if y equals to minus 1 over 2x. X at minus 1 over 2, it will be nothing but minus 1 over 2 into x, that is again minus 1 over 2. The answer here will be a positive. Negative by negative, negative by negative will turn to a positive, and then you have 1 divided by this whole thing here is nothing but 1. 1 divided by 1 is 1. So the function is at 1. The function was supposed to be at 1. At x value, that is minus 1 over 2, the function was supposed to be at 1. But now we cannot draw it at 1. We must draw it just after 1 and where? And up. Remember the hyperbola in that case, it was supposed we were supposed to have something like this, going up and to positive infinity, and then we again negative infinity to positive infinity. We're supposed to have something like this, but now we are restricted only here. We must just sketch only here, and this is the portion of the function that we are going to sketch. So we just come here and then we sketch that portion going up like that, and that is the answer for that. Then we continue and say let's sketch the function that is the following function: the inverse of x if x is e to the power of x. That domain that is given, that is all x values that are greater than 0. Okay, you must know that the function that is e to the power of x is an exponential function. Euler is just a number, constant raised to the power of exponent. It will go like this. Exponential function from high school. It will touch at 1 there. At 0 is to 1. Now we want to reflect it along this mirror. That is our y equals to x. The image will touch at x equals to 1. 1 is to 0 point. So we'll have 1 there. And then the image will be approaching the y-axis. Remember, it will not touch it. It will approach it. It is asymptote. It will approach it but not touch it, and then go like that, following the mirror, go that way. As it goes up this way, it goes this way. Okay, and this function, it turns out, is a function of ln x. Okay, let's go and check it out. When we solve this problem, they want us to the inverse of f. What we do is, okay, we write the very same function, y equals to e to the power x, and then we interchange x and y. X will therefore be e to the power of y, and then we solve for y. When we solve for y, we take ln of both sides. We have ln of x will be ln of e to the power of y. The logarithm rules, natural logarithm rules, allows us to take this exponent to the front of the ln. So we just write our y is equals to, or let me not rush it so that you can see, is our y is going to be y ln e. Y ln e will be equal to ln x, that is natural log of x. Now ln e is nothing but 1, so the function that is the resulting function is just ln x, and that is the function that we must go there and sketch for all x values that are greater than 0. So we just come here and we put 1 there, and then we sketch our ln function going. A ln of 1 is 0, it must touch there. ln of 1, x value when it's 1, the answer is 0. And then you must go check ln of 0 is undefined. It means it will not touch the 0. The function will not exist at 0. It will go towards 0. It will not touch it. It will not touch the y, the value of x equals to 0. The function does not exist there. And then from here, it must go up to infinity for both y and x, positive infinity for both y and x. Okay, it keeps on going up and to the right. So that is positive infinity in both directions. Now let's look at the domain and range of this function. The domain, we write domain, our domain will be all x values, excluding the one that we must exclude. So we just write x is element of all real numbers, but we must say x must not be our first value minus 1 over 2, and x must again be, what is that value, where the function does not exist. At this point, the function will never exist at x equals to 0. So x must also not be 0, because when x is 0, the function is undefined. For both the cases, look at the information that was given. We have here this one, it will make it to be undefined. When you put 0 there, 0 at the denominator will make the function to be undefined. And this one as well, ln of 0. Remember, this function means nothing but the natural logarithm of 0. We have here natural logarithm of x, I mean. So we have the ln x as that function that they are talking about. The inverse of f, there is just a natural logarithm of x, okay? Now from this, that's how we interpret the domain. Let's interpret the range, okay? The range will be all the values of y. Let's check it. All real numbers. It goes to negative infinity because of ln x. There is discontinuity here at minus 1 here, right? But remember, this one is going to fill up that space. Remember, it keeps on going up, it keeps on increasing. So the function will be continuous there, but to the right of x equals to 0. It's only discontinuous here. So we'll only exclude this value when we write domain, but when we write range, we include all of them, because it's going to be, if we exclude that part, then we say somewhere there in the front, the function that is ln of x is going to be discontinuous, and that is not true. There was no restriction given like that to us. Okay, now this is the solution to this problem. Thanks for watching this, and if you're looking for more videos like this, please be sure that you subscribe to this channel, like the video that you're watching, and share this video with your friends. Okay. Oh well, I thought we were done, but then I thought, why shouldn't I give my subscribers a bonus question? Now this one here says sketch the function f of x equals to 5 when x is between -5 and -2. So you know you're going to sketch from -5 there, -5, and then up to 2, -2 I mean. Yes, we have -2 there. And then from -2 to 10, you sketch the absolute value of x when the function is between -2 and 10. So there's -2. Let's say 10 is somewhere there because of space. We won't mind we won't draw up to a scale. Now we say again from 10 to 20, we sketch a constant number that is 5. We sketch y equals to 5. Okay, now what I do, like all the previous questions, indicate these intervals so that you don't make mistakes. You don't jump these intervals that they're indicating for you. Indicate them with a vertical line that is dotted like this. Make a dotted vertical line on each and every one of them. Okay, and also be careful with the limits of these functions as we approach these values, both from the left and from the right, which is a -5, -2, and 10 and 20 as well. It's a 10 here and it's a 20 there. Again, don't forget to do your vertical line at 20. That's what we do. And then we have again going down like that. Now, okay, At minus 5, what is the value? At minus 5, we must include the value of the function, and it should be at 5. There is 5, so we go there at 5, we include the value, we make a dot, and then it's just a straight line, it's just a constant going. It is like it wants to go through the 5, but it cannot go through that interval. Remember, you must stop at some point. This is where we stop. And when you stop, we must open, because the minus 2 is not included. You see, it's just less than 2. All the x values must be less than 2. And so we must just open there like that. Okay? And that is the first part of the solution. And then we want to sketch the absolute value of x when x is between minus 2 and 10. So from here to there, we sketch the absolute value of x. We know the absolute value of x will tend at 0. When x is 0, the function value is 0. When x is 10, the function value should be 10. Should be a nice 5 there. So the function value should be 10. So we just say, okay, we go when x is 10, the function value must be 10 up there. Let's see. We should not include it. Okay, we should not include it. So I shouldn't. We shouldn't shade here. We shouldn't shade here. We should just draw an open circle there, and then yeah, it's on top of our interval. That's good. We are good to go. And then we say at minus 2, the function value is 2. When you put minus 2 as x, you get positive 2. The absolute makes everything positive. Everything that was negative, positive. Everything that was positive, positive again. So the value of 2 is somewhere here. We have 2. You see, I only indicate the values that I will need to plot these functions. So I just minus 2 goes with 2. The point is there, and then I join the points now. But remember, you must come through the origin and then go up to that value there of 10. Okay, it's a straight line. All of them, they are straight lines. The other ones are just constant. The other one is dependent on x. Now, when our domain is between 10 and 20, what we have again is we have the constant that is our constant number 5. Let's shift it so that you can sketch. Now, what we want to do is on the values of x that are between 10 and 20, including 10 and 20, we want to sketch our constant value that is 5, and we must include them, including 10 and 20. And then you draw a straight line that is 5 again. It wants to come there. You see, all these straight lines are 5 because of this first function that is 5 and the second function that is just 5. It's just, they're just constants. But now here in the middle between minus 2 and 10, we cannot sketch that one. We cannot sketch the constant 5. We must sketch absolute value there. Okay, and that's why we sketched the absolute value for that part. Now let's look at the domain of this function. We say that the domain of this function will be, let's look, we start from minus 5, we go all the way to 20. Do we have at a certain point where we just skip that value of x or those values of x? The answer is no, because at minus 2, look at minus 2. Minus 2 is open here, but now it's included here, so we cannot exclude it. It's part of the domain. And let's look at 10 again. 10, let's look at 10. 10 is there, is open. We're supposed to exclude it, provided that here again it was excluded. We're going to exclude it in the domain. But now, since it's included here at this point, you see that x is an element of all the real numbers that exist between our 5 and 20. Okay, and then we close again. We use square brackets, this one, the solid brackets, because we include 5 and 20. If we wanted to exclude 5 and 20, we would use the open brackets like that. Okay, the other notation that you can use to write the very same solution is that you can say just x is between but also equals to both the values 20 and then 5. Oh, it's minus 5. Okay, it's minus 5 there. We must just say it's minus 5, this minus 5. We go all the way from this minus 5 to that 20 there, and that is the solution. Okay, let's look at the range. Range will be given by, let's look. When you place your ruler here, you place it horizontally. It's not perfect, but it will work. We place it horizontally and we want to move the ruler from bottom to up. You see, from bottom to up, you just move it up like that. We are not touching the function. We start touching the function, we only start touching the function at y equals to 0. Please notice that we only start touching the function here at the origin, okay? And then we move our ruler up and see up to where will we still be touching the function, okay? Let's continue to move the ruler up. We're still touching the function, and here again at 5, still touching the function. We continue. Now we must exclude 10, because now 10, at 10, just before 10, that's where the function ends. Just before 10. At 9.99999 with infinitely many nines, that when you round them off, they will probably be 10. But we don't get to 10. Okay, please understand. We don't get to 10. We get to up to just before 10. Okay, and then that's where we end. And so for range, we just write y is an element of all real numbers that are between, we include a 0, and then we go up to 10. But at 10, we must exclude. So a solid bracket for inclusion, and then for exclusion, open bracket. A curved bracket like that, we say it's an open bracket. Ne? Okay. Or if you don't want to write it in this notation, you can just write y is between 10 and 0. But then you must include 0. Okay? Yeah, and this will be the solution. Thank you very much for watching this video. Please don't forget to like, share, and subscribe. If you don't subscribe, when I upload the next video, you won't be notified. Okay? Thank you very much. Bye.